Hey everyone, and welcome. Today, we're diving into the incredible world of machine learning on AWS. Think of this as your guided tour. We're going to take that huge, massive toolbox and get it organized so you know exactly what to grab for your next project. Okay, so picture this. You're ready to get your hands dirty. You've got this mountain of data, and then you open up the AWS console, and you see this list. Linear Learner, XGBoost, K-means, RCF, blazing text. The list just keeps scrolling. It's a lot, right? It can feel totally overwhelming. Where do you even start?
But here's the secret, and it's actually pretty simple. You don't need to memorize every single one of those algorithms, not at all. The trick is to think of it like a really well-organized workshop. All the screwdrivers are in one drawer, all the hammers in another. They're all grouped by the job they do. So once you figure out what kind of job you're trying to do, you'll know exactly which drawer to pull open.
All right, so let's go ahead and pull open that first drawer. This is our supervised learning section. I like to call these the prediction tools. These are what you reach for when you have a really specific question you want answered. Something like, what's going to happen next based on everything that's already happened? Now, the magic ingredient here is something called labeled historical data. And that's just a fancy way of saying you've got a data set where you already know the right answers. It's like you're the teacher. You show the model your past sales figures, and for each one you say, see this? This was a good month. Or this one, not so much. The model learns all the patterns from that data you've labeled so it can then make really smart predictions about new data it's never seen before. It's literally learning under your supervision. And inside this drawer, you've basically got two main types of tools. On one side, we have classification. This is all about predicting a category, a label. It's for yes or no questions like, is this a fraudulent transaction or not? Super straightforward. Then on the other side, you've got regression. This tool is all about predicting an actual number. Not if a house will sell, but what will the final sale price be? So you can think of it as classification for what is it, and regression for how much is it. So what are some of the popular tools in this prediction toolkit? Well, you've got Linear Learner, which is kind of your reliable go-to screwdriver for simple, straightforward problems. Then there's XGBoost. This thing is a beast. It's a real powerhouse. Famous for its accuracy, it's the algorithm that wins a ton of data science competitions. And then you have something cool called K-nearest neighbors, or KNN. The whole idea here is pretty simple. You are who you hang out with. It figures out what a new piece of data is by looking at what its closest neighbors are. Okay, let's close that drawer and move to the next one. This section is for unsupervised learning. And if the first set of tools were for prediction, these are your discovery tools. This is what you use when you don't really have a specific question. Instead, you just have a hunch. You suspect there are some really interesting hidden patterns in your data, and you want to bring them to light. And the huge difference here, the key thing to remember, is that the data is unlabeled. You're not the teacher this time. There are no right or wrong answers you're feeding it. You're basically just pointing it at a giant pile of data and saying, go figure it out. Find me something interesting in there. The model has to explore all on its own and discover the hidden structures and patterns. So what kind of discovery tools do we have? Well, first up is clustering, with algorithms like K-means. This is perfect for automatically grouping similar things together. Think about creating customer segments without knowing the segments beforehand. Then you have anomaly detection, using something called random cut forest, or RCF. Its entire job is to spot the weirdos, the outliers, those data points that just don't fit in. Absolutely perfect for things like fraud detection. And finally, you have tools to simplify your life, like principal component analysis, or PCA. It helps you cut through the noise by reducing a super complex data set down to its most essential parts. All right, and for our last stop on the tour, we have a really special drawer. This is where we keep the specialized instruments, the high-precision tools. These are perfectly engineered for working with very specific kinds of materials, like text and images. So what's in here? Well, for text, you've got tools like blazing text, which is, like the name suggests, incredibly fast. It's built for classifying text or figuring out how words relate to each other. For images, you start with image classification. This looks at a whole photo and gives it one tag, like dog or sunset. Simple, right? But what if you need more detail? That's where semantic segmentation comes in. This is amazing. It doesn't just label the whole image, it labels every single pixel. So it doesn't just see a street scene. It sees pixel by pixel. This is a car, this is the road, that's a tree, and that's the sky. Okay, so we've toured the workshop, we've seen the drawers for prediction, for discovery, and for the specialized stuff. Now for the most important part. Let's put it all together. How does this new organization make that scary, long list of algorithms actually make sense?
And here it is, the main takeaway. You do not need to be an expert in every single algorithm. Seriously. The real power, the real key, is just knowing which category of problem you're trying to solve. Just ask yourself, am I trying to predict something? Am I trying to discover hidden patterns? Or am I working with text and images? If you can answer that one question, you've already won like 90% of the battle. And this chart just makes it crystal clear. Check it out. Let's map some common business needs to our new toolkit. You want to predict future sales prices? Well, that's predicting a number, so you open the supervised learning drawer. You want to segment your customers into new groups you didn't know you had? That's discovery, so you're going to use unsupervised learning. Trying to find fraudulent activity, that's finding the weird stuff, the anomalies, so again, that's unsupervised learning. And of course, if you're trying to understand topics in a bunch of documents or classify photos, you know exactly where to go, your specialized tools. See how that works? It's a super clear roadmap from your problem to the right category of tools.
So there you have it. Your AWS machine learning toolkit is no longer this big, scary, messy garage. It's organized. It's ready for you to build something amazing. So the only question I have for you is, now that you know how to find the right tool for the job, what problem are you going to solve first?